So I've been making a thorough mess in here. That box is actually not to do with that's a box for a work job. But, and that was a smoke machine I used to find whether the air was going through the grill, the radiator of the Buick that I've got. It's been overheating. But this stuff here is actually related to this monitor for the water heater. So I've got power supply, bench power supply, 24 volts, and saturating, but you can actually see there, we got, this is saying it's 25 degrees C, and it's putting out 1.71 volts. And if I look at the screen, that channel is saying 25.26, and that one's 25.2. So we've got them on par. And if I switch over the cover, this one is saying 23.9 at 1.49 volts, and what was that, channel 2, saying 23.9, and you can see 23.93. So I've got those configured correctly, and I'm now working on this. Oh, I should say, this is the screen from the web page that is displayed from this X420 module. On the side here, and the light's not real good, but you see I've been rummaging through my collection of plug packs, and I'm looking for something that I kind of wanted, something that didn't have a plug on the end of it so I don't have to cut it. I've got this old plug pack, and what I want to do is I'll make up a lead that picks up the 240 volts from the pump, and it'll energize this when the pump's on, and this end of the unit will go to a 12 volt relay which I just had lying around. So this is a relay designed for a car horn or similar, lights or something like that. 40 amp, do not need that, but it doesn't matter. And this plug pack, it's 9 volts. So I'm hoping that 9 volts will be enough to switch the coil on this. And then on this module down here, there's actually a 5 volt out on one of these channels. I'd have to look at it. Anyway, one of these is an output for signal, and it's putting out 5 volts. So if I put that 5 volt signal out to I think it's the top one here, this one here, V plus, there. If I send that signal to the contact on this relay and then bring it back in to my digital input, which is these two here, if I come back on the digital one, then that will allow me to trigger this channel here. It'll turn the pump on or off. It'll show that the pump's on or off. We have a winner for our power supply. So 11.8 volts should be enough to switch that. The other plug pack that I was looking at actually didn't work at all, but this one got center pin positive. I'll just have to cut this plug off. It's not the end of the world, and I'm going for this one because it's very low current, output 100 milliamp. So that's not going to drive much at all, and it's really obviously a pretty cheap and nasty little plug pack with a little adapter on it. So if I destroy this well, not destroy it, but if I cut the plug off, it's not going to be a huge loss. And if you want to, you can put another plug on it anyway. So now I'll just wire this up to this relay and confirm that it switches it. Now, I don't know whether you can see, but on this relay is writing here, and it gives me the pins. Oh, it's upside down. So 86 and 85 of the coil, if that's able to be seen. And so we've got on this side the very small writing. They're labelled 85 and 86. And then if I want a normally open relay, it's 30 to 87. So those are the pins I'm going to want. 85 and 86 will be the wires off this, and 85 to 86, and 30 to 87 will be the contacts that I run through for the wire from and to the relay, the web relay. So let's do that. So I've cut that off and discovered that the white stripe is positive just by doing a check on the multimeter. So let's just see if I'll fold this wire back on itself. It's quite small. I don't have many sizes in these spade connectors. So if I can get that to go right up, which I can, I've folded that wire back on itself. This wire back on itself to give it a bit more strength. And then that also fills up some of that gap. So let's do some crimping. Let's go to the middle one. Yep, that feels alright. Now also I don't have insulation around there. I'd prefer it if I had spade connectors with insulation down over the spades, but again, it's not the end of the world. This is just a test rig. This is just to get, if I was doing this for a long-term solution, I would definitely be more careful. Just set that up to make sure I get a good crimp. Okay, so and now let's have a look. 85, 86. 85, 86. So it shouldn't matter which way I put these, because it shouldn't be polarity sensitive, and I can already hear the relay switching. I don't know if you can hear that. There's our relay. Operational. I've wired this in. I actually just took this plug and brought it in through the same connection and put it under the terminals. And I have my little continuity tester. We can see the pump, or at least power tester. You can see the power is there, so we can pick up off that for our signal. So now I just need to do the final little bit of wiring, and I can install this. So here's my dodgy temporary setup. So it turns out that's the 5 volts here, so that's going out to this pin on the relay, and then that return is coming back to analog 1. It's always a bit confusing to me. Red is power, but that's actually power coming back too, so arguably they're both red. It doesn't matter because I know what it is, but it is a bit odd having a 5 volt supply as black I'm just thinking about wiring schemes, but anyway. So I have my power pack that will switch this relay. That relay will close the contact and supply the 5 volts to the input 1, and then I've got my 24 volts. I need 24 volts to run these two transmitters, so that's going to run off my lab power supply for the moment. And I have here a Wi-Fi repeater which I need to configure. It's configured for upstairs, but I need to pick up off this. There's a Wi-Fi repeater here, and the room that I'm putting it in is just over there, so it'll pick it up off that. So I'll just need to configure that, but that allows me to plug this unit in, and that just repeats. So it saves me having to run a wire from that. I could run a wire from here. It's got, you know, I've got a network switch in here that I can pick up on, but if I can get it by Wi-Fi, I will. Because otherwise, I mean, I can run a wire across the top there. I've already got wires there. But if I can, for this temporary thing, so all I need to do now is configure this unit to pick up the Wi-Fi off that router, and that'll let me talk to this. I had that working upstairs, and that's how I was talking to this relay previously. So yeah, just a matter of, I'm going to have to use a dirty double adapter because I run out of power points in there in the laundry. But I'll just go and plug this in, and then I'll see if I can get this configured. And by rights, I should now have this thing operational. So that's plugged now into the tank, and that's the tank measurement there. And it's still equilibrating, I think, but it's within a couple of degrees. Well, 1.5 degrees now. So, and it's still climbing. So that is going to be absolutely near enough for my purposes. So let's now swap it, put in the second sensor. So I've now got the inlet in. That one's reading 40. This one's equilibrating, but very close. So they will it's within half a degree, and with rounding, yeah, it's closing, it's still equilibrating. So it looks like our temperatures are very, very close. That's very nice. 41, 39.8. That is within the noise for me. And we can see that IO1 is high. You can see here, that comes on when that's triggered. So you can see that that's triggering. We can also see that the light is on here, and we can see that the pump's running. So that's picking up the signal and logging it here. 40.1, 41, 40.2. So we're certainly looking like it's absolutely close enough. So last step, get this onto the network, and maybe tidy this up a little bit, but we're nearly there.